Okay, so we've had a look really at what we mean by a regression line. Remember, a regression line is just a line which fits the data or fits the crosses on a scatter graph as best as possible. And there are two different types of regression line. The first one we're going to be looking at is what's called the regression line of y on x. And the main reason that there are two is that they're used for two different things. So let's say you've drawn a line of best fit, a line which fits your data. The regression line of y on x is used if you are given an x value and you then have to use the graph to find a y value. Now, there is one the other way around, we'll look at that later, but y on x is for finding y if you're given an x value. So if you're finding y from x, you use the line of y on x. Anyway, you just need to learn how to actually draw it. Okay, so let's have a look at the steps that you'll need to go through in order to draw the regression line of y on x. First step, quite straightforward. You look at your x values and you find the mean of them. You then look at your y values and you find the mean of those. Okay, and then what you've got to remember is that for any type of regression line, the regression line will always pass through that point which represents the mean of x and the mean of y. And I'll show you how to do that later. What you then do is you work out the gradient of your line. And the gradient of your line is worked out using this SXY and SXX, which you know from the product moment correlation coefficient. We'll remind ourselves how that works in a minute. That's going to give you the gradient of your line. We then find the intercept of your line, and the intercept is worked out by taking the mean of y, take away the gradient that you've just found, multiplied by the mean of x. And then your regression line is y equals a plus bx. Okay, b is the gradient, a is the intercept, or you could write it as bx plus a, doesn't really matter. Anyway, let's have a look at an example. And very often, what you won't be given is you won't actually be given the raw data. You'll actually be given a summary of the raw data. So here we're told we've got 5 observations of bivariate, in other words, x and y data, for 1, 2, 3, 4, and 5. So you've got 5 bits of data. And here are your pairs of data. And you're told that the sum of x is 90, the sum of y is 15, the sum of x squared is 1720, the sum of y squared is 46.86, and the sum of xy is 264. And you're asked to find the equation of the regression line of y on x. Well, basically find it, but along the way find out that the gradient is minus 0.06. Okay, so let's have a look at how we would do that. First thing that you're going to need to do is find the mean. Let's just get a pen. First thing you're going to do is find the mean then of x. And remember, to find the mean of x, you need the sum of x divided by the number of bits of data, which is in this case 5. So sigma x in this time is 90, and 90 divided by 5 comes out as 18. So the mean of x is 18. You're then going to find the mean of y. Now the mean of y is going to be the sum of y divided by n, the number of bits of data. Sum of y is 15. 15 divided by 5 comes out as 3. So in other words, you now know that your regression line of y on x must go through the point 18, 3. And we'll worry about that later. Okay, next thing we need to find then is this quantity b, where b is sxy divided by sxx. Now sxy, you'll remember from the product moment correlation coefficient, is sigma xy minus sigma x multiplied by sigma y divided by n. So in this case, sigma xy, we are told, is 264. So it's 264. Take away sigma x is 90, sigma y is 15, n is 5, and if we work that out, it comes out as minus 6. Okay, we're now going to work out sxx. And again, you remember from the product moment correlation coefficient, that means we do sigma x squared minus sigma x all squared divided by n. So sigma x squared here is 1720. Take away sigma x, well, that's 90 squared divided by 5. And if we work that out, it comes out as 100. We then know that b, this quantity b, is actually just equal to sxy divided by sxx. So minus 6 divided by 100, which is equal to minus 0.06. And that, remember, is the gradient of the line. Okay, we now want to go on and find the rest of the line. So we now know that this A quantity, A, is the mean of y minus B times the mean of x. I'll just write that again then. So A is equal to the mean of y minus B times the mean of x. So A then is going to be, well, the mean of y was 3. The gradient is minus 0.06. The mean of x was 18. And if we work that out, it comes out as 3 plus 1.08. So in other words, A is equal to 4.08. Now remember, A is the intercept. So we now know the equation of our regression line. And now the equation of our regression line, they like to write it as y equals A plus bx. So the equation of our regression line is y equals 4.08 minus 0.06x. Right, if you're then going to plot the equation of your regression line, normally you'd have a scatter graph drawn already, but let's say we're going to draw our regression line of y on x. You can make life easy for yourself here. Don't worry about gradient too much. You know that the intercept is 4.08, and as long as your x-axis goes down to 0, 4.08, obviously I'm not going to do it very accurately here, I haven't got enough scale, the intercept is there. Remember also that your line goes through the point 18,3, in other words, the mean of x and the mean of y. So it goes through 18,3, which is there. And actually, you only need those 2 points. You don't need to worry. Once you've got the intercept, and once you've got the mean of x and the mean of y, that's actually all you need. With those 2 points, you can quite happily draw your regression line. And in fact, there it is. Okay, so that's the regression line of y on x. Now, notice for this question, we were given the summary, sigma x, sigma y, sigma x squared, and so on. If you're not given that information, you'll be given the pairs of data, usually in a table. All you actually need to do is put those numbers into your calculator in the usual way, find sigma x squared, and so on, and do the same as I've just done here.